We'll be starting in a couple of minutes. Ah, yes. Webinar is now being live streamed, so excellent. Let me start sharing my screens. Hi, Joseph.
Good morning.
Morning. Share a screen. Okay. So Joseph, since it's live streaming to YouTube, that means there's no need to record, right? It's going to YouTube, and there'll be a video there later on, I presume.
I
Is that
think so.
yeah?
We can record it here as well, just as a backup, in case it's only live streamed to YouTube.
Yeah. Okay. Maybe let's record the evenings one rather than the morning one.
Okay. Sure.
I think it might yeah, it might be better. What's the word? I don't know. Well, I'll be more able to find words by the evening.
Okay.
Yeah.
Yeah, no problem.
Awesome. Thank you. Hi, everyone. Welcome. We'll be starting shortly. Q&A. Bring up the chat. Okay. Fingers crossed. Welcome everyone. While we're waiting for kind of other people to join in, please feel free to introduce yourself in the chat. Let us know kind of who you are. If you don't mind, sharing, let us know who you are, where you are, why you're here. We'd love to kind of like know a little bit more about you and kind of where did you hear about it? What's your intention for this session? Yeah, it helps us understand a little bit more about, how to fine tune some of these sessions for the future. I'll give a quick intro to myself. My name is Asim Hussain. I am the Executive Director of the Green Software Foundation. I've been in the tech industry for quite a few years as a software developer historically. And my focus in the last couple of years has been the intersection of software and sustainability. I co-founded the foundation almost 3 years ago, and yeah, and for at least the last year and a half, maybe, we've been working with others on what is now called Impact Framework. So we're here today to talk about that. Joseph, do you want to give an intro to yourself?
Yep, certainly. Hello, everyone. My name is Joseph Cook. I am a project manager and developer on the Impact Framework. And prior to this, I was an environmental scientist for nearly 15 years. I was mostly working on developing climate models or components for climate models that dealt with how ice and snow reflect light. And then got more interested in the software development side of things than the academic side of things, and spun out a company and now work on combining the two interests, software and environmentalism, at Green Software Foundation. I've been here for 7 months.
Wonderful. And so, yeah, as I said, for the people who just joined, yeah, feel free to kind of just, say who you are, introduce yourself in the chat if you feel like it. And we just, yeah, love to know who you are and where you are and why you're here, what you intend to get out of this session. So no one's chatted yet. Hopefully that will change soon. So yes, hello Amma. So now we're getting some chats into the chat.
Before you start, Asim,
Go
can I
on.
just ask everyone, if you have questions that you want me to answer while we're going along, please use the Q&A widget, because it's I can keep track of them there, but if they're in the chat, then they just get lost in all the other messages. So if you want me to see it, please use the Q&A widget.
Yeah, sure. And we'll be answering questions as we kind of go along. We'll have moments when it makes sense to kind of stop and answer questions. Yeah, brilliant. Wonderful. Yes, we got a good attendance today. So I'm going to start off really quickly by just talking a little bit about the um, why are we talking about Impact Framework? Well, we're talking about it because we're excited about it. But one of the reasons we're kind of talking about Impact Framework right now is because we're running a hackathon around Impact Framework, which is actually, I believe the start of the hackathon is even next week. But it doesn't matter. You have, even if you're not ready to start next week, as long as you submit something by the end of the hackathon, which is April the 8th. Um, we have, I hope everybody's listed now. Yep. So we have 1, 2, 3, 4, 5. Is that 6 or 7? One, two, that's 7. We have 8 sponsors actually. So we've got this, the hackathon's well sponsored. We have a $40,000 prize fund. Um, and we also have two partners, community partners, Microsoft and Electricity Maps, who are Microsoft's providing Azure credits for anybody to use inside the hackathon, and Electricity Maps is providing data for grid intensity, which I can talk a little bit about here as well. We have a bunch of awards categories, best plugin, and we'll talk a little bit about that. I'll show you what plugin is an Impact Framework. Beyond Carbon is a type of plugin which emits or calculates an environmental impact that's beyond carbon, so water, air quality, anything like that. We really want to see, what's of interest to you beyond carbon. We also have a prize category for best content. So if you're not really, or if you're this is a non-technical contribution. So if you don't want to write code, but you want to write perhaps content or record videos or anything like that, this is a best content category. So maybe you can do a better job creating a workshop than us, or a tutorial, or a how-to video, or even just a case study, even just apply Impact Framework and just try and use it to calculate like a particular area, a particular domain, and just write it up in a really good way, which is kind of educational. That also comes under best content. And best contribution is kind of any software solution which isn't really a plugin. So if you're writing something that makes Impact Framework easier to use, or improving the developer experience, developer tooling around the Impact Framework, or any kind of software that surrounds Impact Framework, that comes in the best contribution. And we also have prize categories for undergraduates and under 18s. So if your team is made up of just undergraduates or just under 18s, we've even got a separate prize category for you, and you can win that in addition to the other prize categories. Let me share some of these links if you're interested. If you haven't signed up already, and you're interested, the most important thing to do is to go here and click sign up. That sign up button at the bottom. So I'm going to share that in the link there. So yeah, if you want to go away and just click that while I'm presenting the rest of the stuff, go for it. And if you're not, share the word, share what's going on as well. Other links I'm going to give you is the actual hackathon is going to be running via the GitHub repository. And so this is where we're going to be, this is where you propose your solutions. This is where you propose your eventual answer. You don't have to check your code in here. We're just asking for people. The first step is if you're interested in submitting a solution, or you've got an idea for something to do with Impact Framework, just create a new issue here and click the template hackathon project, fill out the details, select the prize category you're going for, and let us know if you're recruiting. And if you're recruiting, we'll try and help you find other people for your team. If you've got any questions for us, add them here. My statement is, if you're inspired at the end of this workshop we're about to give you, and you want to submit an idea, if it's very rough, it's fine. It can be a very rough idea, and Joseph and I will kind of weigh in and kind of help guide you if you need guidance. If you don't need guidance, go for it. Lots of people don't need guidance now. They're kind of like, and they're just going for it. So, but yeah, if you feel like it, we'd love for you to get inspired and perhaps submit something for the hackathon. And we really want to help build the ecosystem up for Impact Framework. And I'll share that link as well. Let me go back. Um, if all you do is the most important thing to do is to subscribe to the hack.greensoftware.foundation website. That will get you everywhere. But if you want to get directly to the hackathon platform, we're using GitHub for that. And the final link I'm going to share to you today is going to be useful to you is the Impact Framework documentation here. We're constantly updating it. Some of the stuff I'm talking about today actually isn't in there, but it will be there hopefully by the end of the week. I think we're going to try and like push some stuff out and get some stuff there by the end of the week. Because we're kind of wanting to show you some more bleeding edge stuff that's happening right now. But they got checked in just a couple of days ago. But yeah, that's where we are. Wonderful. Um, let me start, and we can get started with some. Where's my code? Okay, Visual Studio Code. So, what is Impact Framework? Impact Framework is a way to compute the environmental impacts of software. There's a couple of different ways you will probably interact with Impact Framework in your day-to-day life. Impact Framework works with this concept of a manifest file, which is this file which stores absolutely everything required for your computation. So the first thing we're going to show you today is like you got sent a manifest file from somebody. What the hell does that look like? How to navigate it, how to compute it, how to, play around with it and do what we call scenario analysis with it. And the second part of this workshop is we're going to show you how to build your own manifest file from scratch and to compute something that you want to compute. And the third part of this workshop is I'm going to show you how to write a plugin for Impact Framework. It's a framework. It's not necessarily an end solution. It's something that you typically would have to build upon to build an end solution. So it's a framework for a solution. It's a coding framework, and it's built and it's predominantly powered through plugins. Without plugins, it's just a empty box. It doesn't really do anything. So yeah, that's what we're going to go through and show you today. And again, some of the functionality I want to show you today might not be in the very latest public. I don't know when was the latest packages published? Were they recently, Joseph, or
The NPM packages are a couple of days behind
Right.
the main branch of the GitHub repositories,
Okay.
but we're going to cut another release imminently, certainly
Right.
before the hackathon.
Yeah,
Possibly today, maybe
possibly
tomorrow.
today. Yeah. So I'm actually running off the GitHub main branch, but we publish packages to NPM as well, and they'll be coming up shortly. Okay. So I just got sent a manifest file from this dude called Asim. And he sent me this file and he said, my name's Asim. I've computed the impacts of some of my software, and I'm sharing you my manifest file. This is what I've computed. What do you think about it? So he sent me this file, and you can see it's a YAML file, which is a file format. And inside there, it's got a couple of different sections, and I can see that here. Um, I can see it's got this initialize section with these things called plugins, and I can see there's these things that he's configuring at the top with these names: group by, operational carbon, what time. These plugins look like they're coming from some external package place, so that's where they're probably loaded from. And then I can see there's a section called tree underneath it. And inside there, if I look at uh it's got some additional configuration. And if I kind of yes, so I can see here there's a bunch of information, and I can see there's these inputs which look like they're basically some information about some server usage. So I can see utilization, I can see it's on Azure, I can see the region, I can see the instance type, and I can see a timestamp and duration. So he sent me this information. What do I do with it now? So that's what the manifest file is like everything. It's all the inputs, all the assumptions, all the coefficients, everything is all stored in this manifest file. So what you would do initially Let me move this thing to the top. Let me give myself some space here. So Impact Framework is built basically on Node and JavaScript and Node. So to use Impact Framework, you would need Node installed on your computer, and at least Node version 18 or higher is required. And you also need npm installed on your computer, which is the Node package manager. I'm going to show you some stuff on the command line which you need to run to just to be able to get set up to run this manifest file, because you've just been sent a YAML file. You need to download and install some stuff to run the manifest file. And to do that, we use npm and Node. So typically, if you're used to npm and Node, this is going to not be a surprise to you. But if you're new, I'm just going to explain to you how it works. You create a folder on your computer and you type npm init, and that initializes that folder. So after you do that, you can install things. I'm not going to do that because I don't want to ruin the demo at the last minute. So I've done this just prior to this. And the next thing you want to do is you want to install some packages. Now, the ones we recommend to start off with is this is all in the documentation. We'll actually be sending out a very specific email. If you've subscribed to the hackathon, the hack.greensoftware.foundation, later on this week, I'll be sending out an email which is all of this workshop written out. I'm pausing on it right now because some of this stuff hasn't been fully published yet, so I don't want to create confusion. But I'll be sending all this out with all the commands and everything by the end of the week, so don't worry about typing anything or remembering anything. So I need to install Grunsoft, which is our scope on green software. IF is the actual main command line tool. And then we have something called the IF plugins, which are what we call our standard plugins. And then we have Grunsoft IF unofficial plugins. So plugins we've created for other companies, but like we've really, they're not ours, like they are representative in other companies. But we've created some there, and we maintain IF plugins more than we maintain IF unofficial plugins. So you'd run that and get it installed. I'm not going to do that as well because again, I don't want to. I'm scared of the demo gods causing me problems. But once you've done that, you then want to run Impact Framework. So Impact Framework is a command line tool. Its name is IE. So we actually call the command line tool Impact Engine. So IE is short for Impact Engine, not Internet Explorer. It's Impact Engine. And I'm using npx to run it, which is the way I'd recommend it here. And you want to provide it some flags. So minus manifest is the manifest file. So I'm going to pass in asim. Actually, I'm going to call it asim static YAML. And then I'm going to say what I want to output it to. And output is actually a folder. So I'm going to, it's a stub of a file name. So I'm going to output to computed. And I'll explain what carbon is at the end there later on. And there's some like errors coming up from not from our packages, but just from some of the dependent packages. So I'm just making sure that last thing is just making sure that you don't see them. So now I'm going to run that. Fingers crossed. Oh yes, so it's going to take us time. I should have run that whilst I was talking. So it's taking a little bit of time right now because it's a rather large manifest file, and it's actually making some API calls to some external services to get some data. So now it's finished. And what it's now created for me, fingers crossed, yes, is computed.yaml. So now let me take a look at what it's actually done here. So you can see the YAML file is very similar to the one that we sent into it. It's appended the version, but let me just show you what it's done here. So now in my tree, which represents the application that I'm computing, I've got some children, and they're grouped in kind of very useful ways right now. So I've got data, and it's grouped by now the servers. And I've got another node called dev, and that's grouped by these servers. Oh, I shouldn't have done it this way. Okay, anyway. So it's kind of computed it's restructured the tree a little bit. But let me take a look at server one. We had inputs before, And now we have an outputs. So if you look at inputs, it's kind of quite minimal. But let's take a look at outputs. Oh, no, that's just still inputs. Outputs, you can see now has a lot more information. Um, we now have, if you scroll all the way to the bottom, we now have a carbon value. So what this calculated is for this time and this duration, which is a 5 minute duration, this server has emitted a carbon of 2.655. And if I go for the next timestamp and duration, the utilization was a little bit different. And so I'm expecting a different carbon. And yes, the carbon is a bit different. So what we've done is we've been sent a manifest file and I've computed it and I've computed the carbon emissions of this piece of software. It's a bit hard to kind of like visualize some of this stuff when looking at a YAML file. So I'm just going to show you, it also exported a CSV file, which with just the carbon values. So I'm going to just show you what that looks like here. Um, oh, that's hard to see. So you can see it's taken kind of each of those nodes in the tree and it's sucked out just the carbon values from them. And you can see, let's look at server one. Oh, shizzle. I just deleted server one. Oh no, here we go. Um, and if I scroll across, you can see this first column is called aggregated. So in aggregate, that server emitted 119 grams of carbon. I can see at this timestamp, it was 6.17, then it went to 1.5, 7.5, and it kind of emitted. So now I have like a time series of the carbon emissions from that server. And it's also done something very useful to me. It's just aggregated all of that time up. So I know for that whole time is 119. And then it's done something very useful, which is like, because I grouped everything under useful groupings, like maybe this is the data team. It says the data team emitted, it was responsible for 370 grams of carbon, and the entire application in its total is 614 grams of carbon. So that's kind of really what Impact Framework does is it's computing carbon. What is it computing it from? So a really important concept that we talk about here, let me get my notes up. Yeah, is this idea called induction. So what we've basically done is we've taken something we can observe. So I've got server one, and what could I observe from server one? Well, from server one, I didn't really have much information. I knew it was running on Azure. I've grabbed that information. I knew it was running in this region. I knew the CPU utilization was 10%. And then maybe I knew the instance type or some other information. So I had some things I could observe about it. But how do I take this? This is what we call an observation. An observation is one thing you can observe about anything really for at a particular time and for a particular duration. That's an observation. Induction is the process of like, how do we take the observation and step by step turn it into an environmental impact like energy, carbon, water, something like that. And that works through what we call a pipeline of plugins. So what Impact Framework really does, so I've defined this pipeline, and I've said this pipeline is the pipeline I need to induce this observation into the environmental impact I care about, which is carbon. And so it literally is just doing this very simple task, which is taking all of these inputs in the observation. Group by is a function. That's all that group by is. It's just a JavaScript function. Um, and these are some good questions there. I'll answer them live as well, Joseph, if that's all right, because then other people won't get the answer as well. Yeah, okay. Um, uh, so you take some of these, you take this observation and you pass it to the first group by, which is just a function. It's just JavaScript function. Whatever that returns, and that returns just another set of data like this, but with a bit more expanded out. It passes to time sync. And again, that's just a JavaScript function, which then passes it to cloud metadata, which passes it to Teeds curve, which passes it to what time, passes it to operational carbon. And each of those plugins does its own little tiny part in inducing that observation into an impact of carbon. Historically, what's been happening in the space that we're in is people have been writing these, what I now call monolith models. And so a model which does absolutely everything. Like you pass in one thing and it does all these different things and outputs carbon. And one of the things we realized when we were developing Impact Framework is actually the value is in uh, uh, breaking that up. So the same way as you might have like a Linux command line, and each command is a tiny little thing, but you pipe them together and you can get very complex expressions and do very complex things. The same things happens in an Impact Framework pipeline. That's why it's so when you're developing a plugin, the plugins that we've developed are plugins that do one small thing and just that one thing. And that means if you want to do different things, it's easy. You don't have to rewrite a whole model. You just have to change one part of that pipeline. And that's a very powerful part of Impact Framework. And it means it's very modular. It means it's very easy for you to build very complex pipelines just because you don't have to worry about your pipeline. Um, I'm going to talk through a little bit the yeah. And so the last thing I'm going to mention is what's really important is if you see this computed YAML, you can see it has all those values, the carbon numbers, everything kind of like inside the YAML. And I can extract out the carbon value from Impact Manifest and just send people that. But that's not what we want people to do. We want people to send a manifest file. That's the true goal. Like we believe in openness, transparency. We're an open source organization. So we want people, once you compute your environmental emissions, you send somebody a manifest file and you say, well, here's my manifest file. Here's all of my assumptions, all of my data, all of my inputs. Look at it, verify it, validate it, audit it, challenge it, change some of the assumptions, see what numbers you want to do, you want to work. Like the way, like how we've enabled this is by standards. So these plugins have a standard interface. We have a standard way of defining what these parameters are. We have a standard for what the unit should be. And that standardization makes the ecosystem because it means that if you build a plugin to the spec that we have, it will just slot in like a Lego piece. And you can be confident that you can just focus on your plugin and it will just work with the other ecosystem of plugins. So that's basically how the fundamentals of how it works. But a really cool feature of Impact Framework, and I'd like to say this is something I really love, is that really it's you've built a model. And once you build a model, you can do scenario analysis, and that's where things get really interesting. So I'm going to show you an example of that now. So I showed you now like this previously, just this static file with all of these inputs already baked into the file. And that is one way of working it. And there's people that work in it that way. You can have processes that generate the manifest file and then you run the manifest file. How we envision and how some people are starting to use Impact Framework right now is to actually create specific types of plugins, which we call importer plugins. And these are plugins which import the observation from somewhere else. For instance, there's an Azure importer which imports, if you're running on Azure, imports data from Azure, which you then process in a pipeline. So I'm going to give you an example, a pseudo example of that. It's a pseudo example because I'm not really going to be importing data from Azure. I'm going to be using what we call a mock observations or a fake importer, and I will show you that in a second as well. So this is another manifest file. It's pretty much exactly the same. I'm going to go through a bit more detail now. So you can see at the top, there's an initialize section, and inside there's plugins. And this is where we initialize our plugins. And if you want to develop a plugin or use a plugin, you have to put it in the plugin section at the top. You have to name it, and you can name it whatever you want to name it. It's how it could be a descriptive name, which helps you to understand like what is this plugin doing for you in the pipeline. We have different types of plugins. We have standard, very basic logic plugins that multiply stuff together. We have group by plugins. We have plugins that what time is a service which gives you grid carbon intensity, calls an API for those observations and returns data back. We have Teeds curve, which is a model which estimates energy based off of CPU utilization. There's other models you can use out there. Teeds curve is just one of the models. It's a very simple one. We have cloud metadata, which is data that because it's actually really challenging to find like a consistent data source of this instance type on Azure. What is it? Like, what CPU is running underneath it? That was hidden away in lots of places. So we started maintaining that data ourselves. And that helps you get data, important metadata from a cloud instance so that you can use in your pipelines. I've got Fake Importer, which does it stubs your observations, and I'll go through that in a bit more detail later on because I'm actually going to show you how to actually do that. Or I'm running out of time already. And we've got time sync, which synchronizes, and I'll go through some of that right now. So now I've got a pipeline, and the first plugin is my fake import, which is fake gonna suck some data from some service somewhere. Then it's the same as before. Then I'm gonna group it in some useful grouping. I'm gonna synchronize the time, and I'll go through that in a second as well. I'm gonna pass it through all these things and output it. You can see the important thing here is in this particular manifest file, the inputs are null because I'm gonna be importing the data. So let me just run that to make sure it works as I want it to. So I'm just going to change asim static to just asims YAML. Should have done that while I was talking so that I could explain a bit more. But the important thing, and I think something that's really powerful about Impact Framework that is a little bit misunderstood, is that we're building a model of a software system, a model that explains the emissions of a software system. We're not kind of directly measuring emissions from different things and giving you a report, which is useful in other contexts. We're building a model, and the power of a model means you can play around with numbers and change things. Once you like just actually get emissions data, there's nothing you can do with it because it's like, well, there's your number. Because it's a model, we can play around, and that really helps when you're trying to convince people to invest in a green software initiative or try and improve something without putting in the developer effort up front. So it's really useful from that perspective. So hopefully this has worked. Let me just double check. We haven't got an error. Yep, it all looks good. So let me show you some cool ways we can play around with this. Now, oh, I should just show you exactly what the fake importer did. It generated a data which is now grouped in this way. So the fake importer generated this data, right? Okay, let me do some interesting things. So one thing that's interesting is all of my servers are running in a region which is East US, which is the east side of the US. It's East US 2, it's an Azure region. So you can see they're all running on East US 2. And you can see so let me take a look at what the total emissions are when running in East US 2. So let me edit the CSV. So there you go. It's 2585. So 2.5 kilos for this 1 hour period of time for this server is the emissions that's generated from this file, from my server running in East US 2. I might want to ask myself the question, well, hang on. What if I moved everything to a different region? Now, because I'm fake generating data, I can just quite easily move it all to West US 3. East, if you don't know, east side of US has dirty electricity than the west side of the US. I'm expecting this to go down a little bit. So now I can rerun this. Fingers crossed that the data and everything all works out as expected. And this is now generating a slightly different, it's going to pull what's called the grid emissions uh, to for West US rather than East US. So let's take a look at the computed file. Edit CSV. Oh, reload. There you go. So I can see like straight away, just from moving from East US to West US, it's gone down to 561. But also more, I mean, this is where things get interesting because actually it's not just the total. You can see when and where, and actually you can probably, let's see, here we go. This particular time was a little bit higher than everything else. Why? Was it the grid emissions were a little bit higher? Was a server utilized a bit more? You can kind of narrow down now that you've kind of got this viewpoint here. What other things you can do? Well, like oftentimes when you're doing kind of what time is giving you is like the grid emissions for that exact region, for that exact um uh time. But sometimes when it comes to auditing or regulatory reporting or anything like that, they actually tell you, you just got to use our number that we give you, and we're not going to trust other people's data. So then you can basically provide your own value. So what time effectively outputs is, let me make sure I'm looking at the right file. What time is outputting? So you can see here there's no grid uh, carbon intensity value. But what time returns for you is, where is it? Grid carbon intensity. So it's saying for that 5 minute period in that grid at that time, it was 369 grams per kilowatt hour. And maybe then you can see here it's 369 and here it was 372. So 5 minutes later, it increased a little bit. So it's kind of a real-time data. You can then say, well, do you know what? My regulator is telling me that I have to use like the global average is probably closer to 500 or something like that. So then I'll just comment out or take out the what time plugin for my pipeline because I don't need it anymore. And I now want to just hard code or set as a default, grid carbon intensity. And then we've got this kind of defaults aspects of the component. And I can add that in. All that's going to do is basically just copy that into all of the observations for me automatically. So that's another way I can kind of just play around with this manifest file. And it's a model, you see, that's what's really important. It's a model. It's not an actual, it's a model that hopefully from a baseline perspective mirrors your application. But then once you've got that baseline, you can play around with it. You can move regions, you can do lots of other things. So now let's take a look here. And it should have changed. Yeah, it's changed, it's gone slightly lower. What other some scenarios I can do? Okay, yeah, let's look at change the grouping a little bit. So what I've got here is I'm using the group by plugin and I'm grouping by team and then by name. So if you look in the computed CSV, you can see tree.carbon, that's kind of the carbon for the actual whole application. Then I'm grouping by this field called team, and I'm grouping by the name of the server, server 1, server 2, server 3. And therefore I can see actually the data team is responsible for 264 and the dev team is responsible for 185. So I've grouped it that way, but I can group it in different ways. What other ways can I group it? Hang on. I can group it by, oh yeah. So there's also information here that I've put in about, well, what is the actual application? So let me change it. This is just data metadata I've put about my mission. So I'm going to group by application instead. And actually, maybe also I'll just so I know what's going on, I'm going to group by cloud region. Maybe I'm multi-cloud. I can group by cloud vendor. So group by kind of does some really interesting grouping functionality, which you can then use to surface, different information. As you group, you can see, the groupings might surface different information, which might be useful to understand kind of where should I put my effort into. So you can see I've grouped, it's only Azure and it's only West US 3. But underneath there, it's now grouped by I've grouped the application to database, cache servers, and API servers. So I can see all my database servers is responsible for 187. I have one cache server that's 106, and all my API servers are 199. So the grouping kind of gives you that kind of scenario analysis. And then maybe finally, just another little bit thing to show is we also have this thing called time sync. So I've generated or I've imported data, a particular time grid. It's actually every 5 minutes. What time sync allows you to do, and it's quite a powerful plugin, is you might have like different data sources which are pulling in data at different frequencies, different observations at different frequencies. You might have a batch job which runs for 1 hour and you just have one observation for that, or you might have things running observations every minute and observations every 10 minutes and every 15 minutes. And you might have a mix and match of all sorts of things. But that mix and match makes it really hard to do any kind of aggregation or any kind of CSV exporting. So to help out with this, we built something called time sync. And what time sync does, it just snaps everything to a grid, a time grid. So this time grid is like for a 1 hour period of time. We've mirrored it from before. It's every 5 minutes. Let's say every 15 minutes. It's 900 seconds. So I'm going to like run time sync there and rerun. And if I go back to the computer.csv, hopefully this would have worked. It looks like it's worked. Yeah, I've got fewer time buckets. So I don't know if you can see, but it's gone from, it's now 15-minute buckets, right? So the emissions per the 15 minutes is gives you different information as well. And it kind of up samples and down samples as well. So it depends, like you might find information. This is why grouping and aggregation and time sync is so important, because it's not just about the total number. That's like nice to know. What our challenge typically is like, what's driving, like where's that number coming from? Like, is it coming from, I don't know who to contact. I don't know what's going on. And by having different groupings, it kind of can help you surface like, well, where's the problem? I'm going to find the team. I'm going to try and find the application. I'm going to try and find the region where it's a problem. How is everything, slice and dice the data to find that kind of, where is it bucketed in? But you can also slice and dice the data by time, because you might have a problem at a particular time rather than in aggregate. So with the time sync, it helps you to kind of play around with the time buckets to see, well, which time is kind of most of the emissions coming from. So these are kind of tools that we built to kind of help you do kind of lots of scenario analysis, because what you're building with the manifest file is, again, a model of your software's emissions. And once you've got a model, you can play around and adjust and kind of see where things go. I am so delayed right now. So this is we had so much more stuff to talk about. I'll zoom through the next section, which is how to build your own manifest file from scratch. So yeah, so I'm going to build. So what I'm going to do is I'm going to create a new file called, where's it gone? Did I not just click new file? Ah, first.yaml. So we've just been running somebody else's manifest file. How do you build your own manifest file from scratch? So I'm going to put it in there. This is the most basic YAML file. Doesn't really do anything. I'm also going to actually output CSV as well, just for fun. You can see plugins is null, the tree is null. Let's start building this up from scratch. Now, the first thing I want to do is I want to add some of those. I want to import some data. I'll just really quickly answer some of these questions. They're good questions coming through. So is it all about cloud software, or can you compute local? Yeah, you can compute anything you want. A lot of the plugins that we built right now are for cloud, but if you build a plugin that models a laptop or models anything at all, that's the most important thing here. We've got some test observations, just CPU utilization. An observation can be anything. An observation can be number of prompts you've used for OpenAI. Can you take that observation and induce a carbon impact? Can you take that observation and induce a water impact? can you take an observation of page views for a website and induce carbon impact? Can you take an observation of, I don't know, I'm blanking now, but like lots of different types of anything you can observe. You just need to find the plugins that kind of take that through. Maybe you can reuse some of the ones we've built. You probably will need to build new ones. We've only got a few, but with the few ones we built, we're really focusing on cloud computing right now. Let me copy. Yeah. So I'm going to create a type of plugin here, which is called import data. I'm just going to spend a second. I'm not going to explain much on the rest. I'm going to spend a second on this one just to show you how it works. So I've defined a plugin called import data. It is going to load the plugin from this package, which I have to have installed. I should install that at the start. And it's going to call this method on that package, which is called mock observation. It kind of generates observations. Plugins can have global configuration, and they can also have configuration on the nodes in the tree. So this is the global configuration. And in there, I'm saying, look, generate me some observations from this time to this time. Each observation should be, oh, I've got, is that 6 minutes? Let's make that 5 minutes. And I'm just gonna, in this example, very simply, don't need that as well, generate some plugins. I'm going to call it, I've got one component, server one. Do you know what? Let's add two components, two servers. What is a component? A component is something that emits emissions. So it can be whatever you want it to be. It can be a server, it can be a mobile device. Anything that emits impacts is a component. So these are two servers that are going to emit impacts. I think that's all I need. And these are generators, and it's going to basically add these as a static value to these components. But it's also going to add this, but it's going to be a random integer. So this is how you generate random data for your importer. This is a fake importer. It's very useful to you in developing to use mock observations, because if you're developing a plugin which needs kind of data to look a certain shape and a way for your plugin to make sense, rather than kind of having a large pipeline of plugins, you could just create a fake importer and generate that stub data, like the way you generate stub data for like a unit test or something like that. That's what this is all about. And then I'm going to then, in my tree, and I didn't mention this before, but it has a pipeline, which is the pipeline I want to apply. I'm going to call it import data, and that's it, I think. So now I'm going to say run this. So actually, let me take off carbon at the end of it, because that doesn't make sense. Then let me take out CSV for a second, because again, it won't work right now because I haven't exported any carbon yet. Oh, that was too fast. Oh, no, it worked. Nice. And let's take a look at what it's generated. So you can see here, this is what it's generated. It's just generated a bunch of fake data, this time, this duration, this server, this instance type, this and it's randomized CPU utilization. So that's what it's built. Okay. I need to induce this data into Carbon. What are some of the plugins that I can use? Now, the first plugin I need to do is actually, I don't really know what this is. This is like an instance type on a cloud. Like, what is that? Like, what is going on? I don't even know what CPU this is. How am I supposed to like figure out how to compute this? And for this, what we've built is something called Cloud Metadata, which is a very useful plugin, and it generates a lot. It basically, a lot of the models and stuff that exist out there are just trying to kind of suck data from the cloud providers and like get you like static data about things, and they're all out of date. And we've committed, we're maintaining Cloud Metadata. We'll maintain it when a new instance type, new stuff comes along. We'll update Cloud Metadata, and it'll provide you that. Oh, that's a good question. Can CPU utilization be 0 1%? This is one of the ways we standardize. If you use super utilization, it's got to be in percent. Like there's so many problems in this space where everybody's using different units and nothing plugs into anything else because of it. So one of the ways we've standardized is the plugin interface is standardized, but also these names are standardized. Energy is in kilowatt hours, carbon is in grams, grid intent. So you, when you're building plugins, you can have some level of confidence that when you see a value, it is, you know what that means, right? You don't have to be always confused. Oh, I don't know what this is. Like you can have some level of confidence. So now, oh, I've done it again. I always do this. I apologize, everybody. I think I'm gonna go over time. But if you want to hang around, I will definitely would like to finish it off. What have I done? No, this is what I want to do. So I'm going to add cloud metadata. Here's advice. Always edit the input file. Don't edit the output file. It's very frustrating. I do it all the time. Cloud metadata, and now I'm going to run this. Let's see what that cloud metadata plugin did when it added it to it. So here we go. And you can see here in the outputs again, I now have a bit more information. It's returned me information about this server. It's told me somewhat an idea of the physical processor, how much memory, how many CPUs has it got, and very importantly, something called the thermal design power, which is the number of watts this CPU uses if it's 100% utilization. That's very useful because once I've got that bit of information, I can now induce my data to at least energy. I haven't got to carbon yet, but I can get to energy now. I can get to energy. And I can get to energy by using a plugin called Teeds Curve. And that is a model, and there's other models out there that do this. This is a very simple model that takes utilization and TDP and estimates energy. Again, same thing. It's a slightly different path. I had to install this before. I've got a little bit different global config. I'm freaking doing it again. Let me edit the right file. And now what I'm going to do is I'm just going to add that to my pipeline. This is basically how you would develop a manifest file. You're just looking at it, you're seeing what the outputs you got. How can you get from that step just to the next step? What can I use? What plugins can I use? Um, so now let's look at computed. And you can see here, I've got one more field, which is CPU energy. So now T's curve is kind of estimated, and that's in kilowatt hours, by the way. So it's estimated some energy for me. I need a bit more information. I need to know the grid emissions. Now for that, we've got the WattTime plugin. WattTime's a service that you can use. Let me make sure I'm editing the right file. And it generates for you, it pulls in, as I said before, the grid intensity. WattTime calls an API. So you have to have credentials, and we've stored those credentials as environment variables. Do not store credentials in your manifest file. Store them as environment variables. Now all I need to do to use the WattTime plugin, again, everything's standardized. Everything's standardized. So it means that you can just use a plugin, hopefully, by adding it in. Obviously, if you use the wrong, oh shizzle. This is bound to happen. Have I missed something? Oh, hmm, 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 hmm.
See your
Okay.
error message again.
It's actually just looking at it. It's not the cloud metadata isn't returning all the data. It's not returning cloud region what ID or the geolocation actually. So something's not quite run right, which is weird because the other one ran perfectly right. But anyway, I'm going to short circuit this and not use that. I'm going to apologize for this. Demo gods struck. So I'm going to add defaults and I'm going to add the grid carbon intensity. I'm going to say it's 500. That's what the WattTime outputs this value. I'm going to hard code it. Obviously, we've got a little bit of an issue here, but it was bound to happen. There we go. So hopefully that's now got. What's going on? Have I messed up somewhere? I think it'll work actually. Fingers crossed. I'm either doing something really stupid or really clever. No, unlikely to be really clever. So I want to add one more plugin because to kind of convert it all together. So um to get carbon, you need to multiply the energy by the grid carbon intensity. And for that, we've got this thing called logic plugins. There's one here called multiply. I'm going to multiply these two parameters together and output it as carbon. Fingers crossed. I think I'm doing something silly, but fingers crossed this works. And we output carbon. Manifest first, output carbon. Oh, yeah. Grid carbon intensity is missing from the array. Something's messing up. Big style. I've done something wrong somewhere. Cloud metadata. Cloud metadata. Teeds curve. It's like it's pulling in the wrong, but it's not pulling in the wrong one here. Let me, just in case I've done something super dumb, I'm just going to copy that across. No, that's exactly the same. First. All right. The region. Yes. Freaking thank you. Thank you. Yep. Yep. Thank you, Andy. So Andy has realized that I've missed the region off the YAML. And let me pull it in. There we go. So I'd say like building a manifest file is almost like it's almost like we almost sometimes we describe as a domain specific language. It is kind of like a programming language. You do get, I missed a semicolon errors, things like that. It's not we're not for fudging sake. K.
You can just add the grid color intensity to the mocks.
Oh, to the mocks. Okay, something's going wrong with the defaults. Oh, right. Yep. It's a different error. Different error. So
put it in common.
Yeah. Okay. So obviously we've got a little bit of a thing going on here, but we will investigate this afterwards. Let me go through. Freaking thank you. And now we have a manifest file, which is computing carbon. So that's basically how you build up a manifest file. Let's very quickly, in the fastest speed I possibly can do, show you how to do a plugin. So I've showed you how to use plugins that exist right now, but how do you actually build a plugin from scratch? Now, plugins are just other node modules, basically just JavaScript files. So what you would need to do, I'm gonna go just create a folder. I'm gonna make the folder. I'm gonna call it copy. Oh, copy plugin. I've already created a folder. It is empty. Call copy plugin because I'm going to create a plugin which kind of copies some data. And in fact, what I'm going to do is I'm going to explain what copy plugin is going to do. Then I'm going to build it. So I want to build a plugin which just copies some data across. So I want to build a plugin, and the way I like to do it is I actually start off with like, how would I want to configure this plugin? What would I want to call this plugin? So I'm going to create a plugin called copy parameter. It's going to be a very simple plugin, and it's going to copy one of those parameters to another parameter, to another field name. So it's going to it might be useful in some circumstances, but I want to show you how it works. So I'm going to create it. I'm going to call the actual package copy plugin that you'd want to install. The method is going to be called copy. This is the global configuration I'm going to have. I'm also, when I use it, I want doing it again, editing the wrong file. Let me go back to first. There There we go. Copy plugin. And then I'm to use it, I'm going to configure it. So I'm going to add I want to configure, I want node level config for this one. Just pretty much just to show you how to use node level config. So node level config is configuration that you apply per node in the tree. By the way, I'm doing everything on the root node, but you can have subnode. You saw before when there's groupings, you can have subnodes and subnodes. Subnodes, you can have pipelines all the way anywhere in the tree that you want, in the configuration anywhere in the tree that you want. So I'm going to create a copy param, which copies the CPU energy field and sends it to energy. That's basically how I want to use it. So to do that, now I need to create the copy param code. I create a folder called copy param. I then open that up. And I've opened it up here. Oh, no, I haven't. Copy param. Okay, cd copy param code this folder. Okay, let's do here. Let's get everything set up. Okay, inside here, I need to do a couple of things. It's a node module. I'm creating some JavaScript code, so I will need to then type npm in it. And I don't need to do anything as a most basic sense. I'm just going to leave it blank, take all the defaults, and now it's created a package.json file in that folder. I actually will need to create an index.js, which is the actual like main JavaScript file where all the code will go. And the next thing I want to do is, and this is very interesting, if you're developing locally and you want to run it, you don't want to publish it before you use it, of course, you need to use a feature called npm link. And that makes kind of your local folder be treated as if it's something that can be installed somewhere else. So I'm now going to go back into my main thing here, cdif demo and npm link. So you have to link a bunch of things. I'm going to link, what did I call it? Copy plugin? Did I call it copy param? Copy param, I called it. Okay. Copy param. And that then basically is kind of like fake installs it and makes it available locally as like something you can use. And now let me start just adding some code to that place. I should actually be able to, I won't be too delayed. Let me get rid of that. And go back to my code and go back to my index.js. I'm just going to add some code here so you can see how it looks. So this is kind of the most basic code for a plugin. I'm going to show you a little bit how it's standardized. So this is how you create a function in JavaScript. So you're creating a function called Carbon. That takes a parameter global config. And you saw the global config in the initialize section, but this is where you pass in the global configuration. And that's how you can configure your plugin. You do need to create like a metadata object, which is where you tell us a little bit more information about your plugin. For now, the kind is execute. That's all we need to know. The main function that we call is execute, and this is the most important function to know. This is where we pass in all of those inputs in that observations, that time series, that all gets passed in as the inputs parameter. And if there's configuration linked to this plugin in the configuration node, that's where we pass it in as config. And whatever you return from this is what gets passed the next plugin, what gets passed the next plugin. That's it. This execute function is where you need to put all of your logic and all of your code for your thing. It can do some simple in-memory modeling. It can call an API. It can export. It can load from a file. It can do whatever it wants. As long as this execute function just has to return as the data which we pass the next plugin in the pipeline. And then you just return as an object which has the metadata and the execute function. And the last thing is this thing here, which lets JavaScript know to export it. And I'm just logging some stuff now. So fingers crossed, if this fails, oh, let's add it to the pipeline as well. So I don't copy param. And I have a feeling yeah, good. Good, I caught that. So copy param. And now I'm just going to call this. No, not this one. There we go. Ah! Did I npm link it? Thought I linked it. Okay. This copy param. Let me double check. It is a copy param. It is copy param. Did I npm link?
Did you build it before you npm
Did it
linked it?
npm install? Ah, okay. Let's see. Let me try that one more time here. I don't think that's gonna work. Fudge. I think the demo gods have come to visit me today. It's there. I can see it. I can see it's right there. It's there. JavaScript. It's there. Why? What do you mean it's not found? It's right. I'm staring at it. Well, folks, what should I do? Oh, I know. Right, let's do this. Let's kill these. Delete. Let's do it again. Link. Help. Audience. Anybody got any advice? Provided mod invalid or not found. Okay. Let's look in the manifest file. Copy param. Copy param. Copy. Copy param. Copy param. Are all the files saved? Good question. Good question. Good question. Oh, that package JSON doesn't look saved. Why didn't that look saved? Let's try that. Hmm. Is it still there? It's there. I can see it. Index.json. Package log. Package log. Copy param. Copy param. No, I shouldn't have to specify node modules in the it's running IE, which is coming from this, from here or somewhere here. So that IE is coming from here. So it's finding IE from the IF, so it's running it. But why is it not finding copy param? Package log copy param. Package JSON copy param. Main index JS. I'm reaching the point where I think just to avoid anything else, I will just show you the completed code. I promise you it works. Um, Pretty sure there's a space in front when specifying path. Where, oh, no, that's okay. That's just there. Anyway, I think I'll play around with this bit afterwards. It is a live demo. There's always something that's failed, but this is unfortunately, and probably bit of this reason is probably because I'm rushing, and probably become obvious to me in a second what I did wrong. But I just want to quickly show you this is just the finished code. and it basically just calls execute, copies the input parameter, gets it from the, so you can then load up things you want to, in your execute function, you can get your global configuration or get stuff from configuration. Then you loop through the inputs and you do what you need to do, and then you return well, what you were passed in and the outputs. Um, my hope is that that's enough for you to kind of get like a flavor of what it's like to run plugins. It's obviously confusing and frustrating, like all development is. But that's it. This is how simple writing a plugin is. It's a standardized interface. It's like you have to functional execute. It's going past inputs and configuration, return it in this format, and it will just slot into every other plugin that we've built. Thank you all. Yeah, demo gods are definitely real. Oh, some questions. Is the path okay? I don't know. Andy, does the order matching method is before path for this one? Oh, shouldn't matter. That shouldn't matter. If that works, I'll eat my hat. I don't have a hat. No. Okay, we'll figure it out later on. Thank you so much, everybody. And please sign up to the hackathon, hack.greensoftware.foundation. If you sign up to that by the end of the week on that mailing list, I will send out a proper video of this thing with the step-by-step instructions, and we'll be working this time. So thank you all. I'll paste it on there and for you to take a look. And